Okay, today is the chapter 4, actually chapter 14, which, in this semester. This is the fourth chapter that I talk about. In this chapter, we'll talk about database design. Before database is invented, people created a file and they use file. This is a collection of similar records. Files are unrelated to each other except in the code of an application program. Data storage is built around the applications that use the file. A database, what is database? A collection of interrelated files. Okay, records in one file or table are physically related to records in another file or table. Applications are built around the integrated database. So files are looks like this. Information system is here and files are linked together closely. Now information systems are closely linked together with the database. Okay, consolidated integrated data from files. Okay, this will be interacting with information systems. Okay. Now pros and cons and conventional files. Pros: it's easy to design because they are single application focus. Excellent performance due to optimized organization for a single application. Cons: harder to adapt to sharing across applications. Harder to adapt to new requirements. Needed to duplicate attributes in several files. Pros and cons of database. Pros: data independence from applications increases adaptability and flexibility. Superior scalability. Ability to share data across applications, less and controlled redundancy. Total non-redundancy is not achievable, by the way. Cons: more complex than file technology. Some are slow performance. Investment in database management system and database experts. It costs money. Needs to adhere to design principles to realize benefits. Increased vulnerability due to consolidating in a centralized database. Field. The smallest unit of meaningful data to be stored in a database. The physical implementation of a database. Data attribute. Data attribute is called field in physical database. So in the field, there are several keys. Primary key, a field that uniquely identifies a record. Secondary key, a field that identifies a single record or subset of related records. Foreign key, a field that points to records in a different file. Descriptive field, any non-key field is called descriptive field. Records. Collection of fields arranged in a predetermined format. There could be a fixed length record structure or variable length record structures. Blocking factor, the number of logical records included in a single read or write operation. From the computer's perspective, okay, in a single read or single write operation, okay. Files and tables. File, the set of all occurrences of a given record structure. Table, the relational database equivalent of a file. So in relational database, file is called table. They are equivalent. Okay. Now, types of conventional files and tables. Master files, records relatively permanent, though values may change. Transaction files, records describe business events, everyday business events. Document files, historical data for review without overhead of regenerating document. Archival files, master and transaction records that have been deleted. Table lookup files, relatively static data that can be shared to maintain consistency. OD files, special records of updates to other files. File and table design, all the file design methods require the analyst to specify precisely how records should be, such as if it's sequenced or not, file organization, if it's how it's accessed, file access. Okay. Now, database technology usually predetermines and limits this. Okay. Trained database administrator may be given some control over organization, storage location, and access methods for performance tuning. Data architecture, of definition of how. File and databases are to be developed and used to store data. The file and or database technology to be used. The administrative structure set up to manage the data resource. Now, data architecture continued. Data is stored in some combination of conventional files, operational databases, databases that support day-to-day operations and transactions for information system, also called transactional database. Data warehouses, databases that store data extracted from operational databases to support data mining. Personal database, workgroup databases. So modern data architecture looks like this. You have many files, but they are included in data warehouse, and that's also from operational database using everyday event. Operational database, everyday events in the businesses. You can have personal database. You can have a group of people, or you can have a database for the group of people. That's work group database. Data administrator is a data. He or she is a database specialist responsible for data planning, definition, architecture, and management. Database administrator, a specialist responsible for database technology, database design, construction, security, backup, and recovery, and performance tuning. A database administration will administer one or more databases. Okay. Database architecture, the database technology used to support the data architecture. Okay. Includes the database engine, includes database utilities, case tools, database development tools. Database management systems. The special software used to is data special. They are the one that one special software used to create, access, control, and manage your database. The core of database is database engine, and data definition language is used to physically define tables, fields, and structural relationships. Data manipulation language is used to create, read, update records, delete records in database, and navigate between records. So basically, in order to create a database, okay, using database management system, you need to know how to write DDL and as well as DML. So the typical DBMS architecture looks like this. There is a user data with the metadata here and data engine here, and you create the data definition using DDL. You create manipulation of data using DML, okay, and other proprietary language can be used here. And then it's linked together with transaction processing monitor and the application development tools, okay, various case tools, PC database, database management system, and other query tools are connected to end users, okay. Relational database, a database that implements stored data in a series of two-dimensional tables that are related to one another by foreign keys. The physical data model is also called schema. DDL and DML for relational database is called structured query language. Triggers, programs embedded within a database that are automatically invoked by update. Code procedures, programs embedded again within a database that can be called from an application program. So from logical data model looks like this one. You will create a physical data model looks like this one. Okay, customer table, customer number. Each record is here. Okay, record orders table. Okay, orders product table. Okay. Then usually you have a product key, primary key, formal key, foreign key, primary key. Okay, that links together all of these different tables. Okay. And you can also create this one with actual database management system, such as called database available in the PC, which is Microsoft Access. So you put this table here, and you insert the record through here. Okay. So what is a good data model? Good data model has to be simple. The data attributes that describe an entity should describe only that entity. A good data model is essentially non-redundant. Each data attribute exists in at most one entity, except for foreign keys. A good data model should be flexible and adaptable to future needs. These goals are achieved through database normalization. So what is database normalization? We have extensively covered the database normalization in chapter 8. Here we're going to just see a summary. A logical entity is, or physical table is in first normal form if there are no attributes or fields that can have more than one value for a single record instance, instance or record. Logical entity or physical table is in second normal form if it is in the first normal for first, and if the values of all non-primary key attributes are dependent on the full primary key. Logical entity or physical table is in third normal form if it's in the second normal form and if the values of all non-primary key attributes are not dependent on other non-primary key attributes. Conventional file design, how do you do it? Output and input design is typically completed first. Fundamental entities from data model designed as master or transaction records. Okay, master files are typically fixed length records. Associative entities from data model are joined into transaction records as variable length records. File access and organization should be selected either if it's sequential or indexed or hashed, ISAM or VSAM. Goals of a database design. A database should provide for efficient storage, update, and retrieval of data. A database should be reliable. The stored data should have high integrity and promote user trust in that data. A database should be adaptable, scalable to new and unforeseen requirements and applications. A database should support the business requirements of the information system. So logical data form in third normal form is here. We have seen in the previous chapter. Okay. Now we put the physical data model and later on database schema. You have to create database schema as a physical database. Okay. A model or blueprint represents technical implementation of a database. Okay. Also called physical data model. So this is a method for database design. Review logical data model. Okay, and then create a table for each entity. Create fields for each attribute. Create index for each primary and secondary key. Create index for each subsetting criterion. Designate foreign keys for relationships. Define data types, sizes, null settings, domains, and defaults for each attribute. Create or combine tables to implement supertype, subtype structures. Evaluate specified reference integrity constraints. Now, what is database integrity? Key integrity. Every table should have a primary key. Okay, so you don't have to have another primary table. Okay. Domain integrity. Appropriate controls should be designed to ensure no field takes on an inappropriate value. Okay. The value has to be within range that the field is supposed to take. Reference integrity assures that a foreign key value in one table has a matching primary key value in the related table. So data types for different database technologies exist. From Microsoft Access, fixed length character is text. MS SQL, that char size, character size. Oracle char size. Variable length. MS Access, that's text. MS SQL, bar chart or character varying. Oracle bar chart. Very long character. MS Access, that's memo. MS SQL, that's text. Or Oracle long bar chart or long bar chart 2. Integer number, MS Access, that's number. MS SQL, int size, integer or small integer or t new integer. Oracle, integer or number. Decimal number, MS Access, that's just name number. In MS SQL, decimal size, comma, decimal places. Numeric or size, comma, decimal places. Same as in Oracle, decimal size, comma, decimal places. Numeric size, comma, decimal places, or just number. Financial number, currency, money, decimal number. Date, date slash time, date time or small date time, depending on precision needed. Date. Current time, not supported by Microsoft Access. MS SQL timestamp, not supported by Oracle. Yes or no? Yes slash no, MS Access. MS SQL bit. You have to use character 1 and set as yes or no domain. That's one of the methods that you can create this yes or no true or false variable. Image OLE object. MS SQL image. Oracle long row. Hyperlink. MS Access hyperlink. MS SQL bar binary. Oracle row. Can designer define new data type? No, MS Access. MS SQL yes. Oracle yes. So this is a physical database schema that is based on the database model that we just have shown in several pages ago. Okay. So what we are interested in is here this physically you indicate that this is a character or integer and how many bytes that it's gonna take up. Okay. It has to be all very specified. Everything has to be specified. Okay. And which one is primary key, foreign key also have to be specified. Okay. And referential integrity also has to be indicated here. Okay. But I'm not going to ask the referential integrity in the question in the exam. Data distribution also has to be analyzed, established which business locations need access to which local logical data entities and attributes. You can have centralization and entire database on a single server in one physical location. Horizontal database, also called partition. Tables and rows assigned to different database servers and location, efficient access and security. Cannot always be recombined management analysis. Vertical distribution, also called partitioning. Specific table columns assigned to specific database and servers. Similar advantages, disadvantages of horizontal. Replication, data duplicated in multiple locations. Database management system coordinates update and synchronization. Performance and accessibility advantages. Increases complexity. Database capacity planning. For each table, sums all the table the field sizes. Then that becomes the record size. For each table, multiply the record size times the number of entity instances to be included in the table. So that's how many records are there? That's basically multiplied by record size. That's basically table size. Some table size, okay, all of the table will be added together. Then that's database size. Optionally, add a slack capacity of about 10%, okay, 10% that's empty, okay, to account for unanticipated factor. This is the anticipated database capacity, okay. So SQL will be created in SQL data definition language. Will be using this kind of code. Create a database management or database using database management system. Okay, so the class code, class ID, department code, the section code, class code, group code. Okay, and if it's a character or number or null, that sort of thing will be generated. So table will be generated. So alternatively, other tables will be generated. So that's the end of the this chapter. Okay, I'll see you in the next slide. Bye bye.